In this short video I'm going to look at how to draw a regression line using Microsoft Excel. Regression is generally speaking a straight line, although it is possible to get curvy linear lines, but it's possible to fit all sorts of trend lines using Microsoft Excel. As I said, in this case we're just going to look at a regression line to see what it looks like and how it's done in Excel. So first of all, let's imagine we've got I'll put the cursor onto the screen, and let's imagine we've got 12 months here and we've got some sales figures, and we want to see what the trend in the sales figures is over the 12-month period. So how to do this is quite straightforward really. We just highlight that and we'll go to Insert, which is right up here, and we'll insert a scatter diagram, which is, take that one, and you can see immediately we've got a picture of what the data looks like. So that's what the data is. It's not a straight line, as you can see, but it is upward sloping nonetheless. We just wanted to see what a trend line will look like here. Many people, when they're at school and they first meet trend lines, the teacher might say, well, put a ruler in between and try and get the dots on either side of the ruler and just generally try to see what it looks like. It's okay, but it's not very precise. There is a more scientific way of doing it, and the way we'll use is what's known as ordinary least squares. We'll use a regression line. So first of all, the diagram itself, well, let's just tidy it up a bit. Let's go to Layout. So when you click on here, this is the chart we've just inserted. When you click on it, we get these extra tabs here. So we've got Layout, and we can go to Axis Titles, and we'll have a horizontal one which we'll just put along the bottom. Sorry. There. Cursor is too sensitive. We'll call it months, and see if it's gone in. Yes. And we'll insert one also for the vertical axis, and here we'll have, try to be, actually I don't want that. I want it to rotate. So I want it rotated, and I'll type in sales and click outside, and we've got sales. We've only got one series here, so I'll just get rid of that completely. I'll just highlight it and delete it. So now we've got this, which is pretty good. Now I want to fit the line in here, so if we click on this again and we bring back up our menu up here, we can go to trend lines. Now if we click on here, you can see there's a whole list of trend lines we can get. We can get linear trend lines, exponential, linear forecast, and so on. We'll just want the linear one, this one here. So we'll click on that, and there you go, it's inserted straight away. Now that is a properly fitted regression line. Let's see how good it is. So if we go down here to more trend line options, I'll just move this in so you can see it. When I clicked on it, we got this, and just go right down to the bottom here and say display the equation. So now, as you can see, the equation is displayed on the chart. It's over here. And we'll also have the R squared I'll explain that in a second as well. Just put those two on for the moment. When you get used to this and when you get more statistical knowledge, you can play around a lot more and add more to the diagram, or to the chart I should say. I'll just highlight that because I want to make it a bit clearer for you to read. Perhaps increase it a bit as well. Yeah, 14 sounds good. So what I've got here is I've got y equals, let's call it 5. Y equals 5x plus 74. So we know that it's upward sloping, it's positive, and it's got an intercept of 74. If I continued the line backwards, it would touch back here at 74. 74.121 to be precise. And for each month it goes up by 5. Generally speaking, that's what the trend is suggesting. You can see it doesn't actually touch many of these points, but they're above and below it, and what they've done is they've statistically averaged it out, so that's what the figure suggests. And the R-squared, well, that's something that needs to be studied properly. The R-squared is the goodness of fit. It's how well the data fit around this line. So if it was 1, it would be a perfect straight line. All of these dots would lie along the line if it was equal to 1. If R-squared was equal to 0, the dots would be all over and there would be no pattern. It would be impossible to fit a line because there would be no particular shape, no particular direction. It would be up and across and diagonally, and it would be everywhere. So 0, there is no relationship at all between the data. 1, there is a perfect relationship between the data, and as you can see here, it's 0.78, or 0.79, so which is pretty good. When you do statistics to a higher level, you'll have other calculations to say exactly how good is it. 0.79, is it very good or not so good? And there'll be other statistics you will use to measure that. But that's further along in your study of statistics. And if you have done statistics already, you know what I mean. So for the moment, 0.78, anything above, statisticians believe that anything above 0.7 is fairly good. If it's below 0.7, it's not too good. So the R-squared is 0.79 is fairly good. And that's how we fit a regression line using Excel. If you haven't got Excel, don't worry about it. There are lots of, well, there are two that I can think of immediately. Free Office suites, which are freely available. They're online, and it's possible to download those, and they have the same functionality as far as I can see with the Microsoft suite, but they are free, so well worth considering if you haven't got Microsoft, the Microsoft Office set. And that's it. That's how we do it. So thank you for watching.